Welcome to the OpenMP SC Booth Talk series. This talk is going to be about the SOLVE OpenMP Validation and Verification Suite. I am Swaroop Pophale from Oak Ridge National Lab. I'm a computational scientist here. To introduce the team, we are doing this work under the ECP SOLVE project in collaboration with the University of Delaware. And our current team members on the Oak Ridge side are David Bernholt and myself. And on the University of Delaware, we have Josh Davis, Thomas Huber, and their professor, Sunita Chandrasekharan. So the outline of my talk, I'm going to introduce what the SOLVE ECP project is about, very briefly, and the scope and the intent of this particular work of this validation and verification suite. Then a little bit about how OpenMP has evolved to an offloading machine model, and what are the new features in 5.0 that are interesting, the main features. Then we will look at the details of the validation and verification suite, the test design process, a few examples that we thought were interesting while developing this suite, and a little bit about the infrastructure design. We have some sample results from our runs on ECP relevant platforms like Summit and Cori, and some success stories to share. And also we want to engage with vendors, collaborators, other universities, and help them as well as make this suite better. So the SOLVE ECP project is basically enhancing the LLVM compiler, the runtime, as well as provide the latest and greatest features of OpenMP. So we start at adding those features into the specification and following them up with high quality implementations, as well as validating those implementations. And today's talk, we're going to specifically focus on the validation part. So what is the intent, and why did we want to build this VNP? Firstly, we want to verify the status of the OpenMP implementations across ECP platforms. Although the 4.5 and the 5.0 spec have been around for a while, 5.0 came back in 2018, till date, we don't have complete implementations of the same. So when application developers are trying to incorporate OpenMP, specifically because it is portable and extremely widely available, they want to know what features are available, how they can change their applications to meet the changing hardware and the facilities available. So this gives them a good idea of what is available on a particular platform or with a particular implementation. We also want to evaluate the OpenMP functionality and performance on target architecture. So performance, we don't focus so much in this talk because it's it's kind of orthogonal to what the VNP is focusing on, but that is an aspect we are keeping in mind. We want to see that firstly, the functionality, it gives the correct results. If a directive is implemented, a clause is implemented, it is doing what it is supposed to do according to the specification. We also want to check the implementation's conformance to the OpenMP standard, and we want to help applications test their particular motive or the way of using OpenMP before they deploy it on these big supercomputers. So they can potentially test small parts of their applications through our tests and see how they perform or if they are supported. So basically, at the end of the day, we want to verify the platforms are ready for the OpenMP applications. So starting with the OpenMP 4.0, OpenMP moved to a more offloading model. When I say offloading, it basically means that the computation is, along with the data, is packed up, sent over the network to a device where it computes, and then the result of the computation is copied back to the host. Now, this was very, very different from what we had before the 4.0 specification. And this was mainly supported through a new directive called Target. And from there on, the support for different device constructs has been built into 4.0 and beyond. So, and this is what we started with. What is different in 4.5 that we need to test to give the applications confidence that they can use a particular platform and implementation combination? So now we are at 5.0 and 5.1 will be released soon. So what is so different? So some of the important features that are different in 5.0 are the introduction of contexts, meta directives, and declare variants. Additionally, the requires directive. This is a huge change coming from the 4.5 way of doing things, where there was no support for unified memory. One could not query or find out if they were working on a unified memory machine, which basically means that uh, if you made in unified memory, if you make change either on the host or the target, it is to the same memory location. And since there are specific semantics of moving data in 4.5, you could not really verify that if it is unified memory, some part of the work is already done. So you would not be wasting time trying to move data. So this is very important in for the performance aspect of things. We have memory allocators and support for deep memory hierarchies. Deep copy in the sense a structure that contains different elements. We did till 4.5, we did not have the ability of copying those when you just wanted to copy the structure. You had to go in and manually do the movement of data. Now we have a descriptive loop constructs, which is semantic sugar, but it makes the writing of a loop that much more concise and precise. And acquires release acquires semantics, and the first OMPT and third OMPD uh, third-party tool supports. So there is completed support for Fortran 2003 and added support for Fortran 2008, C11, C++11, and the 14 and the 17 variants. So now looking at our validation and verification test suite, I would like to talk about the design process. So if we go through the design process, there are three possible positive outcomes. First, what we do is we are looking at the specification. We are looking at analyzing the directive or an ECP application. And from there, we will write a test for the directive. We try to make our functionality tests as concise and precise as possible, or try to extract the kernel from an ECP application. For that matter, any application that comes to us, so that we can show the critical OpenMP features that need to be tested. Then we have a in-house discussion about the validity of the test after we make it. Sometimes we discover that in some obscure part of the specification, there are some constraints that invalidate the test. If then we go back and reiterate over the test. If it is a valid test, then if there is an implementation available, we go ahead and test it. Sometimes we have found out that our understanding of the specification has been flawed because of the wordings used or how it is phrased. This is a positive outcome because we can take this issue to the specification, bring it to the OpenMP specification discussion, and get those corrections in. If not, our test is correct, we have understood it correctly, but the implementation is giving us wrong results. That means it's an implementation bug, and we file a report with the vendor. And through this uh, precise process, many vendor bugs have been resolved. So once we have a pass, we open it up for review for the community. And then once the test is accepted, we add it to our VNB suite. So what are some of the examples that we have seen which have been interesting while developing this VNV? So the first example is about understanding the specification. Now here is a code snippet. The first box, we are trying to map an array A, the whole array. And in the second example, everything is same, but we are only trying to map half the array. Now, these are nested pragmas, and they both specify a data mapping over the array section. The only difference being that in the top part, the entire array is mapped, and the second, only a portion of the array is being mapped. What we found out was the first one works, the second one does not. Why is that? Because the specification does not explicitly mention this requirement, but it is an implicit assumption from the different interactions of different parts of the specification that there is already going to be a data map of the entire array. And once you try to do a sub array, it says that, oh, that's a problem because you're trying to map something, half of something that is already mapped. So, well, and we found that there were different interpretations of this spec by different vendors. So a simple fix is by adding a map alloc to the inner distribute pragma. This So the Excel compiler, we found out, the IBM Excel compiler in Summit runs this code. There's no complaint, but Clang uh, gives a compile time error, while GCC gave us a runtime error. So it's a mixed bag out there. And to make things clear, we interact with the vendors to get uniform behavior of OpenMP. So in the second example, what we found out is the specification was not very clear. So look at the two code examples there. In the first one, we have the variable share in the shared clause. And we try to map this to and from the device. Now, these are two very different concepts. Mapping is the data movement, and shared is basically telling you how the variable can be accessed. But this is not allowed according to the specification. So we had to find a different way of making this possible. And one workaround that we found was to use default map. And for scalars, if you do to from, that means share would be mapped to from and would also can be used in the shared clause. So these simple tricks and things we discover to make code work can be useful for people who are looking at the VNV, just not for the validation part, but to know how to use these clauses. So a third test that we took from an application. The application is many, many thousands of lines, but this is a simple code snippet which basically checks if the no wait functionality on the implicit task works. So in the first part, the target map, it creates an implicit task. And the purpose of this test is to have the implicit task generated by target no wait go um, asynchronously first, and then the explicit task would be deferred until the implicit task completes uh, because of the depend clause on A. Now, you have to be careful that at the end of these tasks, since the first one can happen anytime, but it has to happen before the second task, um, you have to use the Pragma OMP task wait. And using this test, we found out that one of the compilers had not implemented no wait correctly. And these are the small things that help the applications when they are going towards full scale runs. Now, let's talk a little bit about the validation and verification suite infrastructure design. So it's very simple. It's based on makefile and scripts. We have our own header file. If anyone wanted to just write a test case, it would be extremely simple. Just you have to add a header file at the top, and we provide some macros that make reporting very, very easy. So the design parameters, we have made it as portable. It is portable and it can use different compilers and different systems. We usually provide um, dev files for the different known systems. And looking at one of the dev files, you can easily create one for your own system so that the make script automatically picks it up and supports your system. So this allows for fast addition of tests, and giving different options to the make can divide your compilation and execution phases. And once you set verbose And if you want, you can create log files as well for looking at it or going through it at a later date. Now, this is what the actual folder structure of the VNV looks like. So we have the tests, which are divided by the specification number. The 4.5 corresponds to the OpenMP 4.5 specification and henceforth. And all of them have a separate directory for each of the new um, directive. And within there, we will have test cases that cover most of the common usages, application usages. Then we also have an application kernel folder under each of these versions, which targets specific specification version, and they have been distilled out from applications that are important for ECP or CAR projects. Now, for example, now these are sample results taken a couple of months ago. For Summit, if we want to just have a view of how the compilers are doing in terms of OpenMP support, we run the VNV and we can see these statistics about how good the compiler is in supporting or giving correct results for the implementation. Similarly, we did it for the Cori computer at NERSC. So our personal experience at this point is that IBM Excel compilers are definitely ahead of the curve, but there is a lot of other GCC as well as Cray are catching up. So this is not the only thing. We have a website where you can go, and if you select the results tab here, you can see the different combinations, known combinations, available combinations of compilers and platforms, and you can look at the results of how they are doing with respect to our tests. Remember, this is an ongoing project. We are still building tests for the 5.0 version and constantly adding new tests for the 4.5. That said, we already have a number of success stories. So we have vendors like Cray and AMD. They are using SOLVE VNB to verify the correctness and coverage for the new features that they are adding to for the Frontier platform. And we have vendors like GCC, AMD and Cray constantly communicating over the GitHub to improve the coverage and add some bug fixes, things that we may have missed. And they found out, which is great community engagement. So we, using our test, implementation bugs were identified in GCC, IBM, as well as Cray implementations, which they were very responsive in fixing once we brought it to their attention. The OLCF, which is at Oak Ridge, is using this validation and verification suite as part of the acceptance tests for Frontier, which means that all these tests have to pass in order for us to accept the OpenMP implementation that Cray provides. Also, NERSC has integrated this VNB for testing their 4.5 and 5.4, 5.0 implementations, which is very interesting for us. So what are the different ways we want the community to collaborate with us? Our main medium is GitHub. Everything is open out there. You can look at the tests. You can download them, play with them. You can even, if you find some issues, you can create PRs, solve it, or just leave it a comment there for us to solve. So on GitHub, if you need to check the behavior of your OpenMP application, you can create an application kernel and give it to us, or create a PR, and we will review it and integrate it into the VNV if it is appropriate. If you find some issues, you find something is missing, just again create and submit an issue or PR, and we have a very responsive team, and I can assure you that it will be looked at. So if you have any ideas, or if you just want to chat with us, or if you have more questions, feel free to reach out any of the team members, and we will gladly answer any of your questions. Last but not the least, I would like to acknowledge our sponsor, the DOE Exascale Computing Project, the US Department of Energy Office of Sciences, as well as the National Nuclear Security Administration. That's all I have. Thank you.